absolute value transformations. If we look, the function of an absolute value is a with the bar x minus h with the other bar plus k. A represents where we can have a vertical, stretch, or shrink. Also, if A is negative, or let me write it this way, that means that your graph is going to reflect across the x-axis. So if A is negative, it's going to reflect across the x-axis. Your H tells you if your graph is going to shift left or right. So A is stretch or shrink, H is moves it left or right, and K shows if it shifts up or down. The vertex of an absolute value is the ordered pair H, K. Now, an absolute value function like the parent function graph looks something like this. That's what the graph looks like. I'll change the color so it's easier to see. So if we look at some examples that say describe the transformations, I'm going to list 3 things. A, in this case, is positive 1. H is negative 1. Because the formula says that is negative H. So H is not included with the negative. So when I pull the H out, I take the opposite sign, which is negative 1. Are we good with that? K is negative 3. So if A is just a positive 1, nothing changes. H is negative 1, so that means we're going to shift left 1. And because K is negative 3, we're going to shift down 3. If you don't have to write out H, and K, you don't have to write that out. I just wrote it out right here so you can see where all of my numbers are coming from. On the next one, I'm not going to write it out. A is negative 1. So what does that mean? If A is negative, what happens? Reflect across x-axis. What is H? 0. So does anything happen? What is K? So what happens? So y'all try the next ones. That's actually a reflection across the y-axis. But, think about it. Absolute value. If it reflects across the y-axis, what happens? Same graph. Whoops. Okay, so she said it's a vertical stretch of 2. And the reason why it's a stretch is because when you multiply anything by 2, it increases. So that means it's going to stretch it. And she also said that it's going to shift right 1. The reason why she said it's going to shift right 1 is because h is positive 1, so it's going to move right. Who wants to try the fourth one? Okay. If you want to move it up some, so it's easier, right? It's on that side. Mm-hmm. Alright, so if first he says that we're going to have a vertical shrink of a third. The reason why it's a shrink is because our number, a, is less than 1. Anytime you have a number that is less than 1, it's always going to be a shrink. It's going to get smaller. He also said that it's going to shift left 2, and the reason for that is because h is actually negative 2, not just positive 2. Remember, the formula has the negative h in it. And it's going to shift up 3 because we're adding 3 to the end. So that's just how you describe transformations of absolute values. Are there any questions? Pretty simple so far? Alright. The next part of absolute values is learning how to graph them. So the first thing I'm going to list is my vertex, HK. My vertex, the x value of my vertex is h. But remember, it's the opposite of what's inside here. So if this is negative 1, my h is really positive 1. And then what's my k? Negative 4. My vertex, if I'm going to go back up to my graph, my vertex is the point in the middle of the absolute value. Where the two lines of absolute values meet, that's my vertex. So I'm going to draw my vertex, 1, negative 4. So here's my vertex. If I plug in 2 into my equation, I'm going to have 2 times the absolute value of 2 minus 1. 2 minus 1 is 1. The absolute value of 1 is 2 times 1 is 2. 2 minus 4 is negative 2. Are we good? All I did was I plugged in 2 in for x, and we got negative 2. Remember, absolute values, they reflect over my line of where my vertex is. So that means at 0, I'm also going to have a point at negative 2. Do we see how a was 2? A is my slope. So I went up to right 1. I'm going to go up to right 1. And I'm just going to do it the other way. So go up to left 1. Up to left 1. And from there, I draw my lines. Where did that green dot come from? I don't want it though. Oh, there, okay, fixed it. So that's how I graph an absolute value. Now it also asks for my transformations. From the parent function, what did I do with this graph? I stretched it. How did I stretch it? What did I stretch it by? I stretched by 2. You said I moved it. How did I move it? So I went right 1. Down 4. Y'all try the next one. Right? So what's my A?
Negative 1.
Negative 1. So that means you're going to go down 1 and right 1. Now go back to your vertex. Go down one left one. Go, now from this point, go down and left. And from the other point, go down and right. And you just keep doing that. And that's how you graph it.
Okay. That's your slope.
Mm-hmm.
Your A is your slope.
Yes. Okay, so she said that our vertex was -2, 3, and our transformations are that it reflects across the x-axis. So because it reflects across the x-axis, that means we're going to take our graph and we're just going to flip it downwards. From there, we're going to move our graph up 2, or not up 2, up 3 and left 2. So that's where her graph comes into play. And her vertex is right here at -2, 3. Are there any questions on how to graph it? All right. Oops. Remember, our parent function looks like that, right? So for it to reflect across the x-axis, if I'm going to draw it up here.
Oh, wait a second. Oh, wait. Sorry.
X-axis is this. I reflect across the x-axis like that. So we've reflected, moved it up and left. Okay. The next set of problems we're given the graph and we're asked to find the function and the vertex. The easiest thing to list is the vertex. What's my vertex? 0, -3. A is my slope. What's my slope? 2. If you can find those 3 things, then you can list the function. Because this is h and that's k. So since a is 2, I'm going to write 2 with the absolute value sign. Because I'm going back up to the top of my paper where I'm given this. I'm just filling in A, H, and K into this formula.
How do you know if it's negative?
If it flips like this, think of it as it's eating something. If it's eating the ground, it's negative.
Okay.
If it's eating the air, it's positive.
Wait, where'd you
Okay. That's my vertex. Okay? My next point that I know for sure that it touches an x and a y value that we know is that one. 2 comes from the slope between those 2 points. So we went up 2, right 1. Rise over run. So A is 2. The next part of my function is x minus h, which is -0. Do I have to write that? No. So I'm just going to put another bar. Plus k, but my k is negative. So I'm going to write -3. It was so hard. The hardest thing I've ever done in my whole entire life, right? Alright. Number 8. Someone tell me what to write. What's my vertex?
-2, 4.
What's my A?
-1/2.
Someone else. What do I need to write?
X plus 2. She said put x plus 2 in the box.
Oh, okay. I didn't hear that part. Do y'all agree?
Did you get it right?
Hmm?
Did you put it right?
I don't know. You tell me. Is A -1/2? Okay, so we put -1/2 for A. I put the bar. I do x minus h, but because h is -2, a negative minus a negative is a positive, so it's going to be +2. And if k is +4, you just add it to the outside of the absolute value sign.
Yes, right.
Your answer's right. I swear. Alright, so y'all try these two.
You want to
No, just write the... Try to write the function for these two. That one is. Is that 1/2?
Yeah.
Okay. Yep. Good job. Do you have the same thing as him? Yep. Good job. Mm. What's my H? Okay. What's my K? 3's over here. Or 3's up here. Who wants to do the first one? You got volunteer, Josh.
That's all I need.
Who wants to do the next one?
6.
Who wants to do the next one? Okay. And for the ones that I've checked, y'all all had them right, so good job.
When's our quiz?
Wednesday.
Wednesday.
I think Wednesday.
Why are we taking a quiz on a Wednesday? How many questions is gonna be, like 10?
I can't remember.
Oh, not even that much.
I don't know. This one page. Alright. So check your answers. Does anyone have any questions over how we got any of this?
Say all right, get out.
Yes. Does anyone have any questions? We good?
Oh, I have a question.
Okay.
Not about how you got that done. So how do you know if the x is gonna be negative or not? Like, what would it equal?
I wouldn't worry about it.
You wanna
Because remember what we said, that if it reflects over the y-axis, that's when x is negative. And if I reflect it over the y-axis, it's just going to look the exact same. Does that make sense?
Unless it's like a step.
You reflect first. So. You could. But we're not going to do that today. Alright, the last thing that we're going to talk about today is how to solve absolute value equations. The first step is to isolate the absolute value. It's almost like you pretend that this absolute value symbol is one variable. So we're isolating that variable. So we're isolating the absolute value symbol. Once we isolate the absolute value symbol, we're going to split it up into two different equations. When we split it up, we're going to have the symbol that equals the number that we originally had, and then the second one is going to equal to the opposite. And we're going to solve for x. For example, let's look at the first one. Here's my absolute value symbol by itself.
Yes.
Yes. So I'm going to have x minus 3, what's inside the absolute value symbol, equals 6. Then I'm going to have x minus 3 equals negative 6. All I did was I changed the sign of what it is equal to. That's all you do. And then solve for x. So I'm going to add 3 to both sides. So I get x equals 9. Add 3 to both sides. X equals negative 3. Check your answer. You will not always have two answers. You might only have one answer, one true answer, or you might only have, or you might not even have an answer. It might be a no solution. Always check your answer. If I plug in 9 for x, 9 minus 3 is 6. Absolute value of 6 is, this one works. Plug in negative 3. You have a question? Plug in negative 3. Negative 3 minus 3 is negative 6. Absolute value of negative 6. 6. Does it work? So my answer to this one is x equals 9 and x equals negative 3. Are there any questions so far?
Wait.
Y'all try the next one. Y'all try the next one. Okay, got it.
I'd say 10. X is 12.
It'll be okay.
You want me to work it out, or are they...
Work it out.
When you put that number in, it has to be 15.
Okay, that's fine. You can just leave it like that.
But double check.
Okay, so we got that x is equal to 3 and x equals to negative 2. Let's, as a class, check our answer real quick. 6 times 3 is 18. 18 minus 3 is 15. Absolute value of 15 is, does 15 equal 15? Yes. Now I'm going to plug in negative 2. 6 times negative 2 is negative 12. Negative 12 minus 3 is negative 15. Absolute value of that is,
15.
does 15 equal 15?
Yes.
Yes. So both of my answers check for number 10. They're not? That's weird. Alright, so just found out that 11 and 12 are not what y'all have on
No,
your paper.
11 and 12 on our paper, it's not 11 and 12 up there.
Yeah, that's... Alright, so I'm going to go to a blank page real quick, because do y'all have 2 absolute value of 2x plus 7 minus 4 equals 8? That's what I have on my paper too. So this one is number 13 on your paper. So remember, we're isolating the absolute value. So the first thing I got to do is add 4 to both sides. So I have 2 absolute value of 2x plus 7 equals 12. I want to divide both sides by 2. So that my 2's cancel out. So I'm left with the absolute value of 2x plus 7. I'm going to go ahead and go to the next step where I split them up. So I'm going to have 2x plus 7 equals 6. And 2x plus 7 equals negative 6. Is everyone with me so far? Is that a yes? Okay. So now I'm going to solve for x. I'm going to subtract 7 from both sides. Divide by 2. So that I get x is equal to negative 1/2. And I'm going to do the same thing to the other side. So that I get x is equal to negative 13.5. You have to plug them back into the formula because sometimes they will not both work. Negative 1/2 times 2, negative 1. Negative 1 plus 7 is positive 6. Absolute value of 6 is 6. 6 times 2 is 12. 12 minus 4 is 8. Does 8 equal 8? Yes. So this one worked. This is one answer. Negative 13 halves. Negative 13 halves times 2 is negative 13. Negative 13 plus 7 is negative 6. Negative 6, the absolute value of negative 6 is 6. 6 times 2 is 12 minus 4 is 8 equal 8. All I'm doing is checking to make sure that these x values work for the absolute value.
Wait, so you had to plug that in to the starting point.
I had to plug both of these numbers into this x. You got to plug it back into the original equation. Y'all try the next one. What do y'all think? Do y'all agree with her two answers? Check your answers. Do y'all agree? With both of them? Tiny bit.
Yeah, it's
wait.
actually 7.
Yeah, that makes sense. I was looking
Well, that's not the one I was looking at.
at
The other one's negative 2.5.
Oh.
It's negative 2.5. Alright. With the changes that she just made, is she right?
Yeah.
Yes. And did everyone check your answers? Did they both work?
They did both work.
Alright. So let's look back at the last two. These are a little bit different. Well, the next one's different. This one's do it the same way we just did it. I'm going to divide both sides by 2. So I'm going to have 2x plus 5 equals 11. Okay. I'm just going to change this to a negative 22. Okay. I'm out. Okay. Alright, so this is negative 22. When I divide by 2, I get negative 11. So now I have to change the other one to be a positive 11. Solve for x. Let's check our answers. Are we okay with where I got x equals negative 8 and x equals 3? Are we okay with that step? Okay, let's check our answers. Negative 8 times 2 is negative 16. Negative 16 plus 5 is negative 11. Absolute value of negative 11 is 11. 11 times 2 is 22. Does 22 equal negative 22? Doesn't work. Let's try positive 3. Maybe the positive 3 will work. 3 times 2 is 6. 6 plus 5 is 11. 11 times 2 is 22. Does 22 equal negative 22? Can't work.
Hold on a sec. How do you, okay, so,
I took my negative 8 and I plugged it in for x. So 2 times negative 8 is negative 16. Negative 16 plus 5
say negative 60, negative 11.
negative 11. The absolute value of negative 11 is 11. So this is 11 so far. 11 times 2 is 22. Can 22 equal negative 22? If that can't happen, it does not work. That means we have to check the other one. So I plug in 3. We got 22 equals negative 22. Does that work? No. If neither answer works, your answer is no solution. This is the reason why we check our answers. Just because you got x equals a number doesn't mean that's going to be a solution. I have a question real quick. Anytime that I have, will there ever be a solution for something that looks like this? The answer is no, because anytime you have an absolute value that is positive on the outside and it equals a negative number, you will never have a solution. So anytime you have a positive absolute value equal to a negative number, you will always have a no solution. Because anytime you take the absolute value of a negative number, what do you get? Can a positive ever equal a negative? No. So let's look at our last example. We're given 4x plus 10 equals 6x. I'm going to set 4x plus 10 equal to a positive 6x and a 4x plus 10 equal to a negative 6x. All we're doing is solving for x. I'm going to subtract 4x. So I get 10 equals 2x. I get x equals 5. Then I'm going to do my other one. This time I'm going to add 6x. I do not want to deal with negative x's. I don't like them. So I'm going to add 6x over here. So I get 6x. I get 10x is equal to negative 10. I move the negative 10 to the other side. So I got 10x equals negative 10. Divide by 10. X equals negative 1. Let's check our answers. 4 times 5 is 20 plus 10 is 30. So this one, I get 30 equals. What is 5 times 6? 30. Does this work? Alright. Let's try on the next one. Negative 1. Negative 1 times 4 is negative 4. Negative 4 plus 10 is 6. Absolute value of 6 is 6 times negative 1 is, can 6 equal negative 6?
No.
So I have one answer. Are there any questions over absolute value? No? No?